Hello, in this video, we are going to be looking at mathematical intuition, this time when applied to the combined gas law. So if you remember, combined gas law is when you have three variables that are affecting each other. So it's unlike in Boyle's law, Charles's law, Gay-Lussac's law, and Avogadro's law, where you only pick kind of two variables and look at what its effect is to each other. In this time, you are looking at three variables and how they affect each other, right? So in this case, you have a problem. We have an example here where the pressure of a gas is 2 atmosphere. It has a volume of 4 liters, and it has a temperature of 100 Kelvin. And then suddenly you change the volume from 4 liters to 1 liter, and then you change the temperature from 100 Kelvin to 200 Kelvin. And the question is now, what will happen to the pressure? So in this case, again, you can still look at some of the mathematical intuition, or you can still use some of the mathematical intuition that we talked about. So here you look at what happened to the temperature, and if you notice, the temperature here is kind of multiplied by 2. From 100 Kelvin, it went to 200 Kelvin, so that's times 2. And if you look at the volume is kind of divided by 4, right? 4 divided by 4 is 1. Or another way to say it is it got multiplied by 1/4, right? And then now without solving, you can actually find out what happens to the pressure just by looking at this too and reasoning out that you kind of have to analyze it in terms of the effect of each change. So remember, you change two things. You change volume, you change pressure. You change volume and you change temperature. So you look at the effect of each change to the pressure. So first of all, you look at volume and you say, well, what's the relationship between volume and pressure? I know from Boyle's law that they are inversely proportional. This is another way to write inversely proportional. It means that whenever V goes up, pressure goes down. And whenever V goes down, pressure goes up. So they have an inverse proportionality. So that means they have a different effect. So meaning, if you saw that the volume was multiplied by 1/4 to get to the final state, guess what? Because this is inverse, the pressure will be multiplied by, instead of 1/4, right? Because remember, inverse, it will be multiplied by 4. Okay? Let me get that. Let me repeat that again. You know that volume and pressure are inversely proportional to each other according to Boyle's law. So that means when when the volume changes from 4 liters, multiply it by 1/4 to get to 1 liter, that means the pressure will change, but instead of it being multiplied by 1/4, since they are inverse, it will be multiplied by the inverse of 1/4, and the inverse of 1/4 is 4/1 or 4. Okay? So that's looking at the effect of volume to the pressure. Now, you also change the temperature, right? So therefore, you look at what's the relationship between the temperature and the pressure, because after all, it's the pressure that you're trying to solve. And you know this is Gay-Lussac's law, and Gay-Lussac's law just simply means that they are directly proportional to each other. That means whenever you increase the temperature, the pressure increases, and whenever you decrease the temperature, the pressure also decreases. So they kind of go the same route. So they increase by the same scale, they decrease with the same scale. So the fact that you kind of multiply this by 2, that means the pressure will also be multiplied by 2, because they have the same direct proportionality. Meaning, if this multiplied by 2, then this also gets multiplied by 2. Volume is different because they have inverse proportionality. So if this is multiplied by 1/4, the pressure is multiplied by the inverse of 1/4, which is 4/1. Okay? So now, all you need to do is say, okay, I get it. The effect of the volume is it will be multiplied by 4. The pressure will be multiplied by 4. The effect of the temperature is it will be multiplied by 2. So what happens to my pressure? That means it will be 2 times 4 times 2. So in other words, if you merge this, it will be multiplied by 8. Okay? So because it's multiplied by 8, your 2 ATM will now become 16 ATM. And that's it. You did not even have to use the formal solution for it. But just to kind of check, let's look at if we were right, if this intuition works. So we have P1 V1 over T1 is equal to P2 V2 over T2. And again, we are solving for P2. So here, P2 would be P1 V1 over T1 V2, and then this T2 gets transferred out here, so it becomes like that. So all in all, it's P1 times V1 times T2 divided by T1 over V2. So let's solve now. So P1 is 2 atm, remember? And then V1 is 4 liters. And then T2, remember this is 2, not 1, is 200 Kelvin. And then over T1 is 100 Kelvin. And V2 here is 1 liter. So notice that the Kelvin cancels out, the liters cancel out each other, and therefore you're left with 2 atm. And 2 atm, that would be, this would be 2 times 4, that would be 8, right? Then 8 times 200, that would be 1,600, right? And 1,600, which is the numerator, divided by 100 gives you 16. So you see, you can apply the intuition that we talked about to find out quickly what will be the result, what the result is. But obviously, you have to know already what the effect of volume is to the pressure, what the effect of volume is to the temperature, what the effect of temperature is to the pressure. In other words, you have to know the underlying gas laws, which is the Boyle's law, Charles's law, and Gay-Lussac's law, in order to apply the intuition into the combined gas law, right? Obviously, again, this only works if the kind of the changes that you have is kind of very regular. That means it's multiplied by 2 or divided by 1/4. But if it's multiplied by 1.653, something like that, then you would be better off doing this. It would actually be easier doing this than doing that. But that is the idea there. You can apply those kind of mathematical intuition into the gas law so that you can know the answer even without using the formal calculation for the answer.